Jai Hind everyone, I am Vaishali Rastogi, Assistant Professor in AKGEC. Now I am going to tell you about page replacement algorithm. Let's continue. So what is page replacement algorithm? The page replacement algorithm decides which memory page is to be replaced. The process of replacement is sometimes called swap out or write to disk. Means if I am talking about the replacement of pages, it is if I am talking about the page replacement, it means that we are replacing page from one memory to another memory. It can be from main memory to our secondary memory. Okay, and we have some page stored in our secondary storage, and whenever we want to execute our pages, we have to take them from secondary memory and we have to put into the main memory. So this process basically called swap in and swap out. The page replacement is done when the request page is not found in the main memory, which is also called page fault. Whenever we require any page to execute and we don't found the page inside the main memory, we have to call the page from the secondary memory. This process is basically called the page fault. Means whenever we are requiring any page and we are not finding this page inside the main memory, this is basically what? Page fault. So let's continue with the types of page replacement algorithm. We are having three types of page replacement algorithm. First is FIFO. FIFO means first in, first out. In this algorithm, a queue is maintained. The page which is assigned to the frame first will be replaced first. In other words, the page which resides at the rear end of the queue will be replaced on the every page fault. Another type we are having page replacement algorithm is optimal page replacement algorithm. This algorithm replaces the page which will not be referred for so long in future. Although it can be partially implementable, but it can be used as a benchmark. Other algorithms are compared into this term is of the optimality. Why we are using this page replacement algorithm? Due to the optimal solution. So let's continue with the third page replacement algorithm. Third one is least recent used, means LRU. We also call it in short LRU. LRU page replacement algorithm. We can understand that this algorithm replaces the page which has not been referred from a long time. The algorithm is just opposite to the optimal page replacement algorithm. In this, we look at the past instead of staring at the future. So we have learned about three page replacement algorithm. First one is FIFO, second one is the optimal page replacement, and third one is LRU. What we can understand with this, in short, if I try to explain, we can see that what we have having some request of page in a sequence. So if we are using FIFO, we will take care of the sequence of first come first out basis. We will execute the page on the basis of FIFO process. But whenever I am talking about the optimal page replacement, in this page replacement, we only see to the future. We will see that which page will come first in future. We will always take care of the future string and we will replace pages on the basis of the future string. But in LRU is completely opposite with the optimal page replacement. In LRU, we see that among pages, among frames, which frame has been used later in previous string, and the most first frame we have used, we will remove that. Okay, so let's continue with these three algorithms with the example. I will take a string and I will solve the question with the both three algorithm. You also just start with the example. After solving the example, you may know better how this kind of algorithm works. Okay, so let's start. So first we are having FIFO, first in, first out. We are having one reference string which is 7012030423. 03120, and we are having the condition of number of frames 3. Means in for execution, if I want to execute these string with FIFO, we have condition of number of frames 3. Means number of frame in main memory would be 3. We have only 3 locations where we can put these pages inside the main memory. After the filling of these 3 frames, we have to apply the replacement of pages. Means we can store at a time 3 pages in a frame in main memory. But what if another page will come to the main memory? How we will solve this? So here the page replacement algorithm comes in the frame. So we will use the techniques of FIFO. So let's continue. So here we have the condition of number of frames 3, frame 1 and frame 3. We are having 3 frames. Okay, we will put all these strings in a frame one by one, and we will use the FIFO technique to replace these pages from the main memory. Let's continue. So first we are having a page 7. So if here one more thing I want to tell you, that whenever we have learned about the page fault. What is page fault? Whenever we have any kind of string in our sequence and we are not finding inside the main memory, we have to call it from the second memory. If the page is coming 7 and 7, right now 7 is not here. This is the main memory frame and 7 is not here. So if I am putting 7 inside it, we have to check that if already 7 is available, then it is page hit. Otherwise, it is page fault, or we can say that page miss. So let's start with this one. So we are having 7. Right now box frames are empty completely. So how I will execute this? I will write 7 and we have not find 7 inside the main memory. That's why it is page miss or page fault. Okay, I'm just marking with this mark of page fault. Why I'll tell you later after completing this process. Next element or page we are having as a 0. So 7 already we are having 0, and it is also a page miss because we have not find 0 inside the main memory frame. So we will mark it again. Again we are having 1. So 7 we are already having 0, and now it comes to 1. 1 we have not find already inside. So it is also a page miss or page fault. Okay. Now 2. We are having 2 for the next execution, and right now all 3 frames are full. Here the FIFO will come into the frame. How we will replace current frame, which process, which algorithm we will use to remove 1, 0 or 7, how we will choose that 7 will be removed, 0 will be removed or 1 will be removed. So we are using FIFO, means first in first out, means in among 7, 0 and 1, who has came first? 7. So 7 will be removed. So 2 will be on the place of 7. So we will write 2 here and 0 and 1, and again 2 was not here inside the main memory. That's why it is again a page fault or page miss. Next we are having 0. 0, here you can see that 0 already presented inside the frame. So it is the page hit. Okay. So already we are having 0 inside the frame. So 0 is here and it is now page hit. Okay. So let's continue with the next page number, page 3. Page 3 is in the scenario. So you can see among 2, 0 and 1, we have 3 frames. We have already removed or replaced frame 1. So now we will remove the frame 2 element. Okay. So here we will remove 0 and we will write 3. Okay. And 2 and 1. Again we have seen that 3 was not present inside the frame. Hence it is page miss. Okay. So next we are also having 0. 0, again we are not having 0 inside the frame. So we will remove which one? 2, 3 or 1? We have removed frame 1, we have removed frame 2, we have replaced page inside frame 2. So now the turn is on with the frame 3. So we will remove frame 3 element and put 0 inside the frame 3, and 3, 2 was the so on. And again we have seen that 0 was not present inside the frame. That's why again it is a page fault or page miss. Again we are having 4. 4 is not inside the frame. We have to replace one page and we have to write 4 over here. So which one we will remove here? We will remove 2 and write 4. Why? Because last page was page frame 3. So again we will go in the cyclic mode. We will write here 3 and 0, and 4 was not present inside the frame. So again it is a page fault. So we have seen that we are having 0, 2, 3 here, 0, 2, 3 here. Now 3 comes in the scene again. So 3 is a hit because 3 is already available inside the main memory. So we will write 3, 2 and 0. Okay. So now we are having 1. We have to replace 1 because we are not having 1 inside the main memory. So which frame we will replace? We will replace 2 because we have already replaced frame 1. So 0, 1 and 3. Now we are having 2 inside the for execution, and 2 is not present inside the main memory. So we will just remove 3 and write 2 here, 1 and 0. And again it was a page miss because 1 was not present inside the main memory. Again it is a page fault because 2 was not present inside the main memory. Now we are having 0. 0 is basically already present inside the main memory and it is a hit. So 0, 1 and 2. Okay, so we have seen how we will resolve these strings with the help of FIFO. So we have to find out some values. What these are? We have to find number of page hit. So you can see the number of page hits are 1, 2 and 3. So page hit is equal to 3. And we have to find out a page fault or page miss. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It is 12. So we have seen that we are having 3 page hit and page faults are 12. Complete reference we are having as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So total number of references are 15. We have to find out the ratios, hit ratio and miss ratio. So hit ratio. How we will find out the hit ratio? Hit ratio, we are having the formula number of hits divided by number of references. Means number of hits divided by number of references. So number of hits we are having, number of hits are 3 and number of references are 15. So what is as here one more thing, multiply by 100, multiply by 100. So what we have find out? We have got the 20%. Again we will find out the number of page faults. So we will calculate the miss ratio. Miss ratio, the formula of calculating miss ratio is number of page miss divided by number of references multiplied by 100. So 12 divided by 15 multiplied by 100. So at around we will get answer it at 80. So this is the complete solution of FIFO algorithm using an example. Let's continue with the second one, which is optimal page replacement. Optimal page replacement, we have learned about the theory in our previous section. Now here I am going to have an example of this reference string. Here we have condition of number of frames is 4. So let's continue. Number of frames are 4. Frame 1, frame 2, frame 3, frame 4. We are having 4 frames and we are having some string. Let's start with the optimal page replacement. How we will calculate this? So we are having strings first 7. 7 is not present inside the memory. So we will put 7 inside the frame and it is a page miss. Okay, because 7 was not present. Now we are having 0, 7 and 0 and it is also a page miss. 1, 7, 0, 1, it is a page miss. Again 2, 7, 0, 1 and 2 and it is a page miss. Now all frames are full. Here we are having another string is 0 and frames are full. Here we will use the optimal page replacement algorithm. So 0, we will see that 0 is present inside the main memory or not. So 0 is already present inside the main memory, so it is a hit. 7012. Okay. Now 3 comes into the scenario. 3 is present inside the main memory or not? No. So first it is a page miss, and where we will write 3, we will see first this. So in 7012 we will have already page 7012. We will see that from here to upcoming string which frame will comes in last. Okay, so we will replace that frame which will come in last among 701 and 2. So let's see, start with the 2 we have got, 1 we have got, 0 is here, so 7 we are having at last. So we will replace that frame or that page which will come in last among all these current frames. Okay, so 7 will come in last in this string, so we will replace 7 and we will write 3 over here, 0 1 2. Okay, so let's continue. We are having next 0 is already present inside the frame, so it is a hit. Again 3 is again 4 is not present inside the frame, and we have to remove one frame inside the main memory. So which we will remove? We will see 3 0 1 2 among all these frames which will come in last. So let's start up to this string. 2 is here, 3 is here, 0 is here, and 1 is at last. So we will remove 1 and we will write 4 over here. Okay, 2 0 and 3, and we have not found 4 inside the main memory, so it is a page fault. Now we are having 2 is already present inside the main memory, so it is a page hit. 2 4 0 and 3. Again we are having 3 is already present inside the frames, so it is again hit. 3 0 4 2. Now we are having 0 is already present inside the frame, so it is also a hit. So we have seen that all these frames were present inside the main memory. Now we are having 2 is also present inside the main memory, so again it is a hit. You can see how optimal answer we are having over here by applying this optimal page replacement algorithm. We are following that approach that there is a maximum number of chances that we will found less number of page fault. Okay, so we have written over here up to 2. Now we are having 1. So 1, let's continue with this. 3042, we are having 3042 inside the frame. We will see which frame will we use in last. So we are having 3042 here. See, 2 is here, 0 here, and 3 and 4 are not in use. So what we will remove first? Here we have option, we can remove 3, we can remove 4, we can choose anything. So I will just using my choice. I am just removing 4 and I am writing 1. Okay, so it is a page fault. Here we are having again 2. We will write 2 over here. 1 0 and 3, it is a page hit. We have having 0 is already present, it is a page hit. We are having 1 is a page here we are having 1, it is a page hit. Again we are having 7. Now scenario comes to the 7, and 7 we are having 3012. 7 is not present inside the frame. Let's extend this string. I will write 0 and 1 more over here to continue with this frame. So we have to remove any frame and we have to write 7. Which frame we will remove? We will see 3102, we are having 0 and 1 in upcoming, so we have choice of 2 or removing of 2 and 3. So earlier I have decided between 3 and 4, now I will decide between 3 and 2. So I am just removing 3 and writing 7, 0, 1 and 2. Now I am having 0. So 0 I am having, it was a page miss and 0 is a page hit. Now again I am having 1. 1 is here and it is a page hit. So these all are the page replacement algorithms. Again, if I am trying to extend any of the digit, I can extend with the 0 or 1. I will extend it. So if I am writing again 0 and 0 is also a hit. So 7, 0, 1, 2. Okay. So we have find out all the strings over here. So let's find out a number of page faults and number of page hits. So first I will count the number of references. Total number of references are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 20. 20 are the total number of references. I will just find out the page hit ratio and miss ratio. So what was the formula of hit ratio? Number of page hits divided by number of references multiplied by 100. So here page hits are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. 12. And page faults 1, 2, 3, 4, 5, 6, 7, 8, 8. And formula you know that. So find out the hit ratio. It would be 12 divided by 20 multiply by 100, and miss ratio or page fault ratio would be 8 divided by 20 multiply by 100. Please solve it, and you have already found out the hit ratio and miss ratio. Next I am going to continue with the last of page replacement algorithm, which is least recent used, LRU page replacement algorithm. It is completely opposite to the optimal page replacement algorithm. Here we are also having a string which is 70120304230 321201701, and number of frames condition we are having 4. So let's continue. Here we will just do opposite approach of optimal page replacement algorithm. Here we will just look for the past string, not the future string. Okay. So again we are having number of frames 4. Let's start. So first we are having 4 frames, F1, 2, 3 and 4. Okay. So first we are having 7. It is a page miss. Again we are having 0. It is also a page miss. 1 page miss again because 1 is not present inside the main memory. 2 is a page miss. 7, 0, 1, 2 and 0. Now 0 we are having 0 and we are full with the frames. We will see that 0 is present inside the main memory or not. If 0 is present inside the main memory, it is a page miss, page hit. Okay. So 0 is already present inside the main memory, so it is a page hit. First hit is here, and again we are having 3. Now 3 comes to the scene and 3 is not present inside the main memory. So first thing is clear that it is a page miss. Where we will write 3, it is a problem. So here we will see the approach how the LRU works. We have 7012. We are here and we will see with the past string. So the first element what we have used among this, which that element will be removed. So among the 7012, 2 is here, 0 is here, 1 is here. 7 is farthest to the current element. So we will remove 7 here. We will write 3, 0, 1 and 2. Again we are having 0. It is a page hit. we are having 4 now. 4 is not present inside the memory. We have to replace one frame. So first thing, it is clear, it is a page miss. And where we will write 4, this is the problem. So we will see among 3, 0, 1, 2, which is the farthest. So among 3, 0, 2 and 1. 1 is the most recently used element among all this. So we will remove 1. We will write 4 over here. Okay. So now we are having 2. 2 is already present inside. So it is a hit. 3 is already present inside. It is a hit. 0 is already present inside. It is a hit. 3 is already present. It is a hit. 2 is already present. It is also a hit. 1. Now 1 comes into the scene. We have to, we are seeing that there is 3042. We have to replace one page because we have to write 1. Which page will be replaced? This is the scene. So let's see. The old leftover the string was there, and we will see among 3042 which frame were you first. So 3042, 2 is here, 0 is here, 3 is here, 0 is here, 4 is the least recently used page. So we will remove 4 and we will write 1 and so on. Again it was a miss. So we have written 1. Now we have 2. 2 is a hit. We have 0. 0 is a hit. We have 1. It is a hit. Now we are having 7. 7 is a miss. So where we will write 7? Among 3012, we will write C over here. 1 is here, 0 is here, 2 is here. 3 is a recently used frame. So we will remove 3. We will write 7 over here and so on. Again we are having 0. It is a page hit. Again we are having 1. It is also a page hit. Okay. So again we will count the number of hits, number of page faults. So let's count first the number of references total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. So you can see over here that 20 number of frames, number of references total used, and the number of hits are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Number of hits are 12 and page faults are 1, 2, 3, 4, 5, 6, 7, 8. Again here we have found out that 8 faults were here. So we have to calculate the hit ratio and miss ratio. I have told you the formula. I am just repeating it again. For finding out the hit ratio, you have to use number of hits divided by total number of references multiplied by 100. And again for finding the fault ratio or miss ratio, you can use number of faults divided by total number of references multiplied by 100. And you will find out the answer. Please calculate it and you can comment over here the answer so that I can reply on that comments. Okay, so it is all about the 3 kind of replacement algorithms. So let's continue with another topics in our next video. So stay tuned. Thank you.